You're listening to the N2K Space Network.
NASA's Chandra mission went to space 25 years ago this week. And while the more spectacular visuals from Hubble and Webb might more easily grab our attention, Chandra has been plugging away all this time, completely blowing astrophysicists' minds. That is because Chandra revealed to humanity all sorts of information that we could never have seen from Earth before. And today, I get to speak to one of the astronomers working on it. Welcome to T-Minus Deep Space from N2K Networks. I'm Maria Varmazes. Our guest today is astrophysicist Jonathan McDowell. In his day job, Jonathan is an astronomer at the Center for Astrophysics, Harvard and Smithsonian, working on the Chandra X-ray Observatory Space Telescope. But it's his out-of-hours work that attracts a lot of attention too. Jonathan has become the leading voice in the United States for chronicling the history of the space program and keeping track of space debris. How does one become the keeper of all things space debris? Planet 4589 has the answers.
I'm Jonathan McDowell. I'm an astronomer at the Center for Astrophysics, Harvard and Smithsonian. And for my day job, I hunt for black holes and help with the running of the Chandra X-ray Observatory Space Telescope. But I have another life in which I have for decades been chronicling the history of the space program and maintaining the website with the list of all the rocket launches and all the satellites and figuring out what they do and trying to provide an objective and global view of humanity's push into space, both with people and robots. And you know, I find that a lot of the coverage, particularly in the US, is very US centered and is very, you know, NASA talks about NASA, but it doesn't talk about non-NASA stuff and so on and so on. And so I felt there was a gap in both being objective and being global.
Many people may also know you by your handle, Planet 4589. That's when as soon as I see that handle anywhere in an article, I'm like, oh, I know who this is. My first question is, how do you do all this? You have in your bio-orbital police, and you are the source of information. When all these different bits of debris were falling, like in Saskatchewan and whatever, I said, unless you have verified it, I don't know what it is. So how do you do all this?
Well, for a start, I depend very heavily, right, on the work of the U.S. Space Force and other agencies and on amateur observers who collect orbital data. My special skill is in putting it all together and doing some math to interpret and tie the strands together. And so, you know, part of it is that I've been doing this for 50 years, since I was a teenager. You know, when an obscure old satellite comes up, you know, oh, Cosmos 1408. Oh, I know that one. You know, and so it's it's having the information sort of at my fingertips, having a mental map of all the stuff that goes on, having the math skills to do some, you know, relatively simple orbital mechanics to tie what people are saying to what's actually happening. And I have about 100,000 lines of code, of C code that I use to kind of do various tasks and automate various tasks. And everything I do is optimized so it takes me the minimal amount of time, you know, to deal with something, because I do have another day job, right? So I've got it down to a fine art where, you know, 95% of everything is automated, and then I can go in and run a specialized program to kind of plot up, for example, the ground track of a re-entering spacecraft over Canada, and do that very quickly because I already have the code canned and I know what to do to make that plot. And so it's really all about. People make fun of my website because it's so.
I love your website. No, unironically, I love it though.
I'm glad. Yeah. And thing is, you know, the younger generation, right? They're like, well, you know, you're barely using CSS. I added that a few years ago. Before then, it was really 1994 type web stuff. But the thing is that a lot of it is generated by C code. and updated. And so I can, or on the Jonathan Space Report itself, it's actually a text file that I type in, and as I type, it appears on the web. And so none of this, intermediary, and all of that is like just making it really, really fast for me to get the content out there. If you want pretty, my data is CC BY. It's Creative Commons. You can copy the data and put a pretty interface on it to make yourself happy. But I don't have time to make it pretty. I'm optimized for that. Yeah, and that's that.
Yeah. No, I was going to say, I don't doubt it, because to me, it is the sheer amount of information that you are putting out is, I'm not surprised it's automated. I would never imagine that was all manual. That would be, I think, impossible. Or
well,
just
to be
terrifying.
fair, the actual list of 60,000 satellites, each line there is typed by hand.
At some point, yes.
At some point since the 1980s when I was doing this. So it's not all of there's a lot of manual, but it's kind of just what do I do and what do I not do? Yeah. So
yeah, I imagine you must have many anecdotes over the course of years of how your information has proven helpful to people, not just randos like me going on Twitter and going, "Oh, what was that?" I mean, you are cited all the time. And this is not your day job. It's just amazing. Any anecdotes come to mind? Because I'm just really curious.
well, for example, there was the time when the Space Command lost a European astronomy satellite for a few months, and they were putting out extrapolated positions for it. And then the asteroid observers found a new object in Earth orbit. Oh, this isn't an asteroid. We don't want this. And I figured out that it was actually this integral astronomy satellite, and it had made a maneuver, and Space Force hadn't noticed it made a maneuver. They were still looking for it in the old orbit and issuing data as if it were still in the old orbit. And so I was able to put the right people in touch with the right people and clear up the error. So there's a few like that. There's been a few cases where, again, things that were originally cataloged as asteroids and then they maneuvered. I
Give me
was
more of
able
that too.
yeah, I was able to figure out which lost spacecraft it actually was. So that's some of the stuff that's most fun. And then it's I get informal contacts from various bits of the government who go, yeah, we can't say it, but we use your stuff. So that's very gratifying. And I think people like to be able to quote my open source stuff. Even if they have insider knowledge that they're not allowed to, they can at least quote me, So
I respect that. The fact that it's open source is just such a service, truly. And I'm a big fan of open source, so I'm just kudos for that. So okay, I want to switch gears to the pub question of where does space begin? This is you sent a really very piece of research, or your own work, I should say, about that very question, which people like to argue all the time. So can we put this one to bed finally, once and for all?
I wish. I mean, the ultimate thing is, right, I'm fascinated by boundaries. And this is not the only boundary that where to draw lines, right? Because as humans, we need to categorize things. We need words for them. And we need to define those words. But also, the English language is a word doesn't have a single definition. There are multiple senses of every word. And so it's okay for space to be used in multiple senses. And indeed it is, right? We have like non-space senses of space, like I need some space, man. And living space. And so that kind of thing, right? So, but even outer space, right? How you choose to define it may depend on what purpose you have. And so it's not important to go, this is the definition of space. What's important to go, this is the definition of space I'm going to use, you and I are both going to use for this purpose, right? And so for the purpose of talking about satellites, I made the argument that the boundary of space should be at 80 kilometers, not at 100 kilometers, as some people have suggested. And what's interesting about that is a lot of people talk about the Kármán line and talk about the Kármán line being 100 kilometers. But in fact, when Kármán first calculated it, he got 84 kilometers. So and then the 100 was just a round number picked up later. because in the context of the 60s, people were not confident that the upper atmosphere was stable enough to make it a well-defined boundary using Kármán's argument, which is when does lift or drag become more important than orbital dynamics? And so, I went back and looked at that with modern atmospheric models. I went, oh, well, actually, no. Although, the atmosphere at 300 kilometers is bumping up and down a lot, the atmosphere at 80, 90, 100 kilometers is actually pretty stable. And so for a lot of different atmospheric conditions, when you ask this question, where is gravity or atmosphere more important? It comes in the 70 to 90 range at worst and never goes out to 100. And so then if you look at where the satellites actually go, there are a few satellites in elliptical orbits which dip down to 85, 80 kilometers. But whenever they dip down to 70 kilometers, they don't come out again. And so that's a pretty hard lower boundary from the empirical data. And so the fact that the empirical data and the theoretical data agreed meant that I thought, okay, this is nice, right? Is I'm coming at it from two different angles, and they're both giving me the same answer. And so that gave me some confidence that, okay, this is a pretty solid result. That multiple lines of argument are leading me to it's more like 80 than 100. And if you arm wrestle me, I mean, if you want 85 or even 90, yeah, okay, I can't argue against that. But 80 is sort of the middle of the range, and 100 is too high, in my opinion. Other people have different opinions, and that's fine. And I think, like I said, the most important thing is to say which definition you're going to use. And if you want to use 100, that's fine. But don't say that some other definition is absolutely wrong, even though I think 100 is kind of wrong. But
don't say it's wrong, even though something might be wrong.
But
well,
let's say it's not a physically motivated choice. But for some purposes, it may be the sensible choice to use, and I'm open to that.
We'll be right back after this quick break.
I think that's a very fair answer. I often think people would say 100 because it's a number that's easy to remember. I think it really comes down to that for a lot of people linguistically anyway. It's just 100. It's a round number.
But here's my thing, Maria. That now the question is, what do you pick on Mars?
Oh, my goodness. What a great question. What do we pick on Mars?
What is the Kármán line for Mars, right? And so if you're just going with round numbers, you're not really helped. Whereas if you have a physical argument, right, then you can go, well, let's do the same calculation for Mars that we did for Earth. Where does gravity and aerodynamics, and it's a little, I don't remember the number, but it's like 60 or something like that, But you can do an equivalent calculation for any planet with an atmosphere.
Mm-hmm.
Right? The moon's a little harder. So if you are standing on the moon, are you still in space? Well, arguably yes. So
if you lightly jump on both feet, then
but even if you don't, right? So that's a bit. So I'm still struggling with what to do about that. But I think that having a physically motivated definition for Earth lets you extend that definition to other worlds, and so it's more robust in that sense.
Okay. I love that answer. It's also a framework answer, so it's setting us up for success in other worlds. It doesn't let people argue about whether or not these space tourism flights are space or not. That's the one. It's everybody's favorite pub arguments, but I feel like I like your answer better, to be honest with you. So I think it's very fair.
And to be clear, so I pick 80 for all my work, and so I do count these space tourists on Virgin Galactic as having been in space, and I call them astronauts in that particular sense of the word.
I think that's great to hear. I'm always curious where people fall on that one. Again, it's just a pub question, really. I'm always
Well,
fascinated by answers to that.
that's the important thing, right? Is answering the pub questions. Yeah.
It's true. It's true. All right. So I'm going to switch to the other thing that you do all day, which is Chandra. So I imagine things are still very busy at this wonderful institution. What I mean, it feels a little overly simplistic to say, well, what's going on right now? Given that I'm sure a lot of things are going on at once. Any sense of what you can tell me what's happening right now?
So, Chandra is the X-ray cousin to the Hubble, and it was launched in 1999. And I remember standing at the pad, next to the pad, watching it go up on a pillar of flame, going, "Please don't blow up." And it was I'd been working on it several years before that, so I've been working on Chandra for a long time. It sees the hot universe that Hubble and James Webb can't see. And so if you want to study some region of space, you need both the Hubble and James Webb data and the Chandra data to get the full picture of what's going on. And if you don't have both, then you're really, you're missing a significant part of the story. So we have, the particular things that Chandra is excellent at seeing are the freshly baked elements from supernova explosions. And we can so here's a couple solar masses of newly made iron. Here's some silicon. We can see it in the shock wave as it expands outwards at 20,000 kilometers a second, and glows at 1,000,000 degrees. And the other thing we're really great at is looking at what I call gravity reactors. When you have a large source of gravity and gas falling into that, it gets squeezed by that gravity and gets hot. Now, if the thing at the middle is a supermassive black hole, say, once the matter goes into the black hole, you can't see it, famously. But you can see it when it's being squeezed on the way in. And it gets squeezed to millions of degrees, and so it puts out X-rays instead of ordinary light. And so we can very easily spot where all the black holes are. And we've released a catalog, possibly as an updated version of our source catalog, that has about 300,000 black holes in it. And so that's been really great to be able to sort of map out where are the energetic events in the universe, basically. And we've been pushing that further and further. When I started on Chandra, we never thought we'd be able to see quasars, black holes at early stages in the universe. We thought we'd have to look at the nearby ones. But now, with some good tricks, we've been able to see ones at redshifts of 6, which is not long after the Big Bang. And so we're being complementary to the discoveries that James Webb is making about that early phase in the universe. And one of the big questions, right, is when did the lights turn on? And were the lights that turned on first the fusion reactors, the stars, or the gravity reactors, the quasars? And so that's an ongoing question that we're trying to figure out. Did the formation of the stars in the galaxies then cause matter to fall into the middle of the galaxy and feed the black hole and turn them on? Or did the black holes form early and the energy input they put into the surrounding galaxy trigger star formation or affect it? And so that interaction is very complicated, and we're just we've got the first few objects that we've studied, and we need hundreds more. So there's a lot of really groundbreaking science still to be done with this 25-year-old telescope.
And it's got a lot of life left in it, at least another decade, I've heard. So lots more to be done.
That's right. I mean, so the thermal insulation is getting a little crinkly, and there's a bit of fog on the lens and so on.
Happens to us all.
But yeah, I know exactly. I'm definitely creakier than I was 25 years ago, and so. But we're still doing. The demand for Chandra is as high as ever. We're doing several observations a day. So each 2-day orbit of the Earth, it looks at maybe 4 or 5 different things. And so the results just keep rolling out. So and there's nothing obvious that's going to break, that's going to stop it working. One day, right, it'll stop talking to us. Some power supply will blow or something like that. but there's no reason for that to happen in the next few years, I think. So I'm hoping that as long as the funding support is provided, we can carry on delivering great science. And I think we run a lean mission, and we're very proud of the work that we do with Chandra.
Is there anything else that we should make sure that you've got an audience right now, I'm sure you're used to it, but if there's anything that you wanted to say to the audience before we close out, the floor is yours. Anything you want to mention?
Well, I think one thing there's a couple of things that I'm really pushing on right now on the space side. One is the risks associated with uncontrolled reentries. And so we've seen that with the Dragon trunks crashing down. We've seen that with the piece of the ISS that hit the house in Florida. And I think we really need to look at the regulation of these reentries, and sort of let's not do that. Let's bring them down under control, even if it costs a little more money. The other thing I'm really pushing on is regulation of deep space activities. So we're entering a new era in space exploration where the frontier is moving out. And the frontier used to be kind of low Earth orbit, and beyond that, only the superpowers played. And now the frontier is moving out to the asteroid belt, and everyone from developing countries to startup companies is going to be sending stuff to the moon and Mars, and it's going to become just part of the general playground. But it's much less regulated than Earth orbit. And so we need to require things like make public your trajectory, say what you're doing, have some kind of flight plan, right, in the public domain, so that there's transparency. Again, going back to this open source thing, let's have some transparency in the process here. And the commercial companies don't want that, of course. They want to do things like, I want to go to an asteroid, but I'm not going to tell you which asteroid I'm going to. And yeah, space is big, but no, let's at least have a public flight plan. So I'm making that argument in various forums. And the other area that I think people should know about is and that plays into both of those other two ones, is the development of the commercial space activity in China. Because we hear a lot about, SpaceX and commercial stuff in the US, but China has really made a shift in the last 5 years or so towards lots and lots of startups that are not, associated with the government. They're really going capitalism in a big way. And so you have all these new players that are not then used to the norms we have. They're not going to send their identifications of which satellite they are to the U.S. Space Force because, China. And so we need some better international way of coordinating space activities that brings the Chinese commercial sector on board. And that's absolutely critical to safe use of space, sustainable use of space in the decade to come.
That's it for T-Minus Deep Space, brought to you by N2K Cyberwire. We'd love to know what you think of this podcast. You can email us at space@n2k.com or submit the survey in the show notes. Your feedback ensures we deliver the information that keeps you a step ahead in the rapidly changing space industry. T-Minus Deep Space is produced by Alice Carruth. Our associate producer is Liz Stokes. We are mixed by Elliot Peltzman and Trey Hester, with original music by Elliot Peltzman. Our executive producer is Jennifer Eiben. Our executive editor is Brandon Karp. Simone Petrella is our president. Peter Kilpie is our publisher. And I'm your host, Maria Varmazis. Thanks for listening. We'll see you next time.